Voilà, on va reprendre, s'il vous plaît. Donc, alors, on va passer en fait à la partie internationale. So I'm going to switch to English, and we have a big pleasure, in fact, to have on the University of Bordeaux site three representatives of a big partner of the university in general, but of IASVV in particular. Which is University of California at Davis. It's a major actor in the field of agricultural research in the world. And in fact, we have a link with Andy Waterhouse for many reasons. In fact, some of us, in fact, went to postdoc to Andy's lab, and Andy also was for several years a member of the scientific committee evaluating on a two-year basis, in fact, the scientific activity of this institute. So the way we are going to do it is Dan Hall, consul des États-Unis donc en France, is going to introduce shortly the delegation, I guess, and then we'll give Gary May the microphone to talk about the global policy, in fact, I believe, of UC Davis in terms of research, and particularly concerning agriculture. And then Andy will focus on what the policy that this very famous university has in terms of viticulture. So, thank you very much.
Thank you, Mr. President. It's a real honor and pleasure to be here this afternoon for the 10th anniversary of this institution, and also for the occasion of the visit by Chancellor May and the delegation from UC Davis. Cooperation between the United States and France is something we talk a lot about at the consulate, often in historical terms. Lafayette. Soon, of course, we'll mark the 75th anniversary of D-Day. That'll be an important moment. And then later this summer, here not far in Biarritz, the eyes of the world will turn again to the region for the G7. But this region, of course, is so wonderful for its wine. And that's something that brings everyone together. And at any rate, it's a pleasure and a privilege to be invited to participate this afternoon. And without further ado, I think I'll pass the microphone. Thank you very much.
Thank you very much, Daniel. And thank you, University of Bordeaux, for hosting this event and at the IASVV. We are very happy at UC Davis to extend our appreciation for the invitation to be here today. And today's visit is actually the part of my very first visit to France with a UC Davis delegation. I've only been at UC Davis now for 2 years, and we're all honored to be here in one of the world's great wine regions. I'm very proud of our history as collaborators in scholarship. Bordeaux and the University of California have been peer institutions in grapes and wine since 1880. Over these decades, we've exchanged faculty and students regularly. We've reviewed one another's progress and met at numerous international conferences. So thank you for your friendship and spirit of cooperation. At UC Davis, wine very much defines who we are. Our roots began in 1908 as the University Farm, which was a research and science-based extension of UC Berkeley. Now we're home to nearly 40,000 students ourselves, with viticulture and enology as two of our greatest specialties. One of the first things visitors see as they enter our campus, in fact, is a 120-acre vineyard that's used for grape breeding programs, rootstock trials, and other research. So it's an exciting time to study viticulture and enology, with global wine production setting new records in 2018. In California, the 2018 growing season was acclaimed by vintners for moderate weather and strong yields. But more than ever, we must look ahead. We must strengthen the connections between viticulture and the STEM fields, science, technology, engineering, and math. We must continue to advance viticulture through new technologies, not just for the art of winemaking, but for finding ways to be better stewards of the land. The world of wine and grapes face major challenges in the near future. Many wine regions around the world are facing loss of agricultural labor. Global warming and other environmental factors are an increasing concern for winemakers. In California, droughts have led to a series of disastrous wildfires, including some of our most prized wine regions. Australian vintners have faced similar issues. At UC Davis, our Robert Mondavi Institute for Wine and Food Sciences is now helping California's wine industry learn about managing smoke taint as wildfires become the new normal. These and other challenges will require substantial innovation across the globe. It will take our best research institutions to tackle these issues that seem to magnify each year. UC Davis and the University of Bordeaux are ready to lead the way. These are two of the very few institutions that have the capacity and the creativity to advance the technology fast enough. We are at the forefront of educating the next generations of wine scientists and showing the industry what's possible in terms of sustainability, quality, and best viticulture practices in a rapidly changing world. So we have some very tough questions to address. Bordeaux has been the premier export region for a millennium, but will our famous vineyard regions, whether it's the right bank of Bordeaux or Napa Valley, hold their standing in the face of climate change? Our advancing scientific knowledge will help answer those questions and lead to new innovation. Maintaining traditional quality will depend on true innovation and insights based on fundamental understanding of plant physiology and other areas of science. This is especially true in vineyards, where pest control remains an age-old challenge, but climate change will bring even new challenges in quick succession. So to date, we have mitigated fungal diseases with novel fungicides, as well as the traditional use of sulfur. However, we face growing resistance to the use of chemicals in the vineyard. So we must face a new set of questions. Will we be able to develop benign treatments, or will we need new disease-resistant vines? Either path will break new ground, paths only available to those with a strong scientific foundation. Then we come to questions related to workforce. Will the global wine industry be able to advance as the labor not only becomes more expensive, but also less available? In California, the agricultural industry has faced labor shortages for years. Those effects are pronounced in the wine regions of Napa and Sonoma. In fact, according to a UC Davis study, 87% of vineyard management companies reported labor shortages in 2017. Estimates suggested that Napa was short by more than 1,200 workers that year. So the question we face is, can mechanization help manage these kinds of labor shortages? The future of mechanization sounds promising, but fulfilling this vision won't be easy. Automation of hand labor involves a very complex, multidisciplinary approach that includes sensing, sophisticated motor control, and other issues that will be challenging for most researchers. At UC Davis, our researchers have a vision about the farm and farm workers of the future, and it's called the Smart Farm, an initiative that includes research on intelligent farming machines and even robots that would replace weeding by hand. We're looking at tractors of the future that would be self-driving vehicles, along with robots for precision planting and applying pesticides and nutrients. However, all these challenges, from labor to climate change, will require multidisciplinary approaches. Viticulture and enology will remain at the heart of moving these technologies forward. But to manifest these visions and create a global wine industry for the future will require collaboration from many sides. Electrical and computer engineers, like myself, roboticists, climate scientists, and many others will play key roles in finding solutions for the collective challenges faced by wine. So once again, I hope that we can remain in a spirit of cooperation. Our research support agencies need to put aside their parochial limits to funding and encourage international collaboration. I look forward to capitalizing on new agreements to advance the sustainability of grape growing and winemaking with the research capability and creative energy our two sister institutions have. So once again, I thank you for the invitation to be here today, and my hope is that we can continue building on our long-standing collaborations and advance the global wine industry to the future. By joining forces across the spectrum of sciences, I think we can do just that. Thank you very much.
Thank you, Chancellor. I'd like to follow that up with a few more personal remarks. First, I'd really appreciate the opportunity to be here today at this important time at ISVV. As was mentioned, I have special connections. The University of Bordeaux have had numerous visitors from Bordeaux over the years. In fact, just one of my graduate students came here just a couple of years ago and just left. She did a postdoc here, so we continue to have this connection, personal connections. And so I've had a number of visitors from Bordeaux, but I'd like to mention one whose name has come up several times, Pierre-Louis Tecedra. Was a postdoc with me in Davis many years ago. I won't say how many years ago. And we worked on phenolic compounds, which you've all heard about. And we actually published some of the early work on antioxidants in wine. So the story about wine containing antioxidants really got started in a small research team at Davis, and Pierre-Louis was a key researcher in that team many years ago. Now, obviously, he's a member of the faculty here at the university, and he's now a leader in the international education, particularly with Viti. But Pierre-Louis is very active over the years in building bridges, international bridges across to Europe and back to Davis. And we're very happy to be a participant in that international collaboration. And as also was mentioned earlier today, I really want to recall that I was a recipient of this university's honorary doctorate or honoris causa in 2008. It's a tremendous honor that I remember and cherish today. Later, I had the privilege of watching the growth of the ISVV over a number of years as a member of the Scientific Review Committee. And from the beginning, we could see an evolution in perspective and practices, so that today the ISVV has really become a gold standard in interdisciplinary research, which was really, you could see, it took an effort to do that. But really now, I think ISVV is really doing excellent work with viticulturalists, chemists, enologists, working together to solve really difficult and complicated problems. I agree with the Chancellor that the challenges we're now facing will require real, true innovation and capabilities that cross many disciplines and skill sets. And ISVV has the right spirit to foster that innovation. We also believe in collaboration at UC Davis and have various administrative structures to encourage that at UC Davis. And most of our faculty in our department work with teams across the campus to tackle very difficult problems that involve genetics and chemistry and so on. We hope that we can extend this collaboration to the University of Bordeaux for the very difficult challenges that will be facing us in the near future. I've had a long research interest in wine and health, and actually started with that early work with Dr. Tecedra. In fact, we're both current members of an international review team that looks at new papers on wine and alcohol and health. It's very clear that the medical data shows that moderate wine consumption, not heavy consumption, moderate wine consumption is clearly linked to longevity and improved quality of life. I think this gives us important motivation to work together to ensure the future of wine, which, if you may have seen some recent papers, there are definitely people out there who don't think anyone should be drinking alcohol at all. And they're doing their best to try to disprove this very clear data that wine consumption in particular and in other alcoholic beverages actually improves longevity and reduces disease. Good wine should be accessible and affordable to everyone. But as I'm going to show with a couple of examples, the many variables that simultaneously are present in viticulture and enology make resolution of the research questions we face very complex and call out for multiple teams to work together to find solutions. In our tour today, we heard about a few of these, and I think we all have the same impression. The effects of grape processing to make wine involves many overlapping variables. So you start with grapes, and you go through a seemingly very simple process, but the complexity can become overwhelming. We should be able to cooperate on studying this issue by taking up separate questions or coordinating our efforts. An example I would offer is the interaction between the grapes, the microbiome, the bacteria, the yeast of the fermentation, and the physical process of making wine. Many winemakers are now using multiple yeast or bacteria to undertake the fermentation. In the old days, we all just used Saccharomyces or natural yeast, and now people are actually adding multiple yeasts, so it adds to the complexity. We can construct controlled experiments to manage the presence of specific microbes, but it turns out each one of those microbes transforms different amounts of flavor from the grapes into the wine and transforms different amount of color precursors into color. So there'll be interaction between the use of yeast and other techniques that are designed to alter flavor or color during winemaking. For instance, one of the other techniques, winemakers use certain techniques to mix up, to macerate grapes to extract color and tannin. However, the microbes that are used can alter that process so that the transformation of the tannin and the color into the wine is actually altered by the specific yeast or bacteria that are present. So if you change your yeast, you may have to alter your maceration technique. Also, many winemakers are now introducing limited oxygen during the winemaking process. In California, we're seeing this growing across the business. This stimulates the formation of stable wine pigments. However, it also stimulates yeast growth in different yeast. So if you introduce oxygen into your fermentation, you suddenly now have a different microflora. So you now see the interaction between the physical process, the chemical process, and the microbial process. Some bacteria will rapidly produce, or yeast will rapidly produce acetaldehyde, which causes color stabilization. But if you have specific bacteria present, at the same time, they will consume the acetaldehyde, diminish the color stabilization. So if you're using a mixed microflora fermentation, you start using micro-ox, that technique to increase color stabilization, if you have the wrong bacteria present, it will have no effect whatsoever. So the complexity here can become apparently overwhelming. So once we decide what experiment to undertake, then we have to figure out what are we going to measure. Phenolics, aromas, tannin, color, terpenes, esters, thiols. All this adds to an experiment. So you can do a winemaking experiment, and at the end of it, you have to measure various things. Here we saw rooms full of machines. Actually, I was pretty impressed how many machines you actually have. Sort of amazing. But you have machines, you have to analyze so many different variables to really understand what happens in a winemaking experiment. So even with the resources here, I would argue that there are too many things to have one institution actually undertake a real resolution of these issues. And so really it would take a collaboration. And the other thing I want to mention, since I'm here in Bordeaux, I very recently heard that wine drinkers and sommeliers to some extent are now starting to ask for different wine. Okay? So I'm very happy to report that at least in high-end restaurants in the U.S., this is the top-end restaurants, the U.S., Parker's tyranny has been crushed. So Robert Parker's say-so does no longer determine what wines go into the market in the high-end restaurants. I've been waiting for this. I'm sure you've been waiting for this. It is actually happening. A friend of mine told me that he had a winemaker, a very extremely well-respected consulting winemaker in Napa who had his own little brand. He got 100 points from Parker, and his distributor told him, "Oh, you'll never sell it now." Meaning in the very top restaurants in New York, San Francisco, Los Angeles, Dallas, Chicago, the sommeliers are not interested in a 100-point Parker wine. They will not put it on the menu. So he can still sell it, but he will not get the prestige of being at 11 Park Avenue, et cetera. So the world is changing. What that means, however, is at least for us, some of the research we've done now on Cabernet is maybe not going to be relevant in a few years. In other words, the market's going to shift. We currently consider Cabernet to be sort of the standard grape. If you want to do an experiment, you do it on Cabernet, but in 5 years, we may say, no, no longer. Anyway, I'll try to come up. So I have one other example, which of course is all facing us today, and that's climate change. Rising temperatures leads to greater rainfall, but also faster evaporation. So what we're seeing in California is we have two problems. We have floods in the winter and the spring, but we're still having drought later in the summer. So the water's coming in greater amounts and then evaporating so fast that we're getting drought at the end of the season. So the heavy rainfall presents very big challenges to basic farming. How do you get in the vineyard if it's completely saturated with water for months on end? Farmers are starting to use a cover crop, which we had used to provide competition in the spring for the grapevines, but actually it turns out the cover crop actually makes it possible to get into the vineyard as well. But if you start introducing cover crops, now you change other dynamics in the vineyard. So once you tweak one part of the ecosystem, other things start to happen. So now you have to deal with plant nutrition, changes in flavor development, pest management, mold development. All these things are affected interactively in the environment of a vineyard. And this really points to the complexity of the situation. So effective solutions will definitely require multiple disciplines to address them. Warming days and nights also affect the development of flavor, and the complexity of tastes and wines means that multiple pathways to flavor-related compounds will be affected. So as we look at grapes grown in different regions, we know that grapes grown in warmer regions sometimes don't have the same flavor profile as grapes grown in colder regions. If we're going to tackle this, at the very least, we have to analyze how climate affects gene expression, transcription, and the ultimate microbiome of a grape, because all those parts are needed to understand the mechanism of the process. This will be a major effort. There will have to be a major effort to address these questions with genetic expertise, plant biochemistry, physiology, et cetera, to see how the vine responds to changing climate. And as you well know, grape composition does not directly translate into wine composition. There's a transition there that involves, as I mentioned, a lot of complexity, including microbial transformations. So temperature change leads to a lot of differences in the grape and resulting in the wine. And the temperature alone cannot be considered in isolation. The rainfall, remember, all those things interact. So it's very clear when we go about trying to figure out how a small rise in temperature is really going to affect winemaking. It turns out it's a very, very complicated situation. There's a host of responses of unexpected consequences. If we hope to preserve our traditional quality in wines from traditional regions, or even just produce quality wine from a specific region, we face very complex problems that demand multifaceted response. It will take a joint effort to provide this response. I hope we can find the administrative and scientific means to cooperate so that good wines can remain important and accessible to consumers, and the appreciation of wine quality and enjoyment make viticulture and winemaking a sustainable venture into the future. Thank you.
Thank you very much. I think what you talk about was also had a good resonance with our scientific program during the day, climate change. The challenge also of having robots in the vineyards, and all these are topics that are of interest for us, of course. And we already have started to start some of the program. And what I like also very much is that the complexity of the system is probably, and it's an appeal, in fact, for us to collaborate, because it's not possible for one group to be able to answer so many a question with so many variables, and we need to think about bringing big data together and trying to compare the system and try to move forward. And I think also your experience also with global warming, which is probably different to what we, but in some way at least, probably a little bit different. But it's also something we have to follow. You talked about also pathogens. You also have specific diseases. We all have specific diseases, and the way it's managed should be compared, and I think it's we can learn lessons from each other very much. So thank you again. I don't know if there is if someone has a question for our UC Davis representative. No? Our president.
I really wish to thank you very much for coming today. It's a great opportunity. I mean, we cannot miss that. And I'm just president for 2 months, and we are together. So you've been 2 years, if I understand very well. I'm only 2 months, so I'm very shy. But I'm sure with Alain and the rest of the team, we will find the ways to solve the administrative matters you mentioned. Thank you.